For this example here, we want to divide 222 by 3 in base 4, where we have to understand here that, for one, 3 doesn't go into 2, but when we're looking at moving over a digit to talk about 3 going into 22, that's not the same as when the 3 goes into 22 in base 10, where it'd be 7 with a remainder of 1. Instead, when we're looking at this type of long division, it's probably been a little while since you thought about long division. I know it has been for me outside of other contexts. We have to be mindful of the fact that if we're trying to put, oh, excuse me, I lost a 2. Let me erase that. I was a bit ahead of myself. If we're trying to deal with that, we're trying to get how many times 3 goes into 2, we want to understand for ourselves that 2 is something more like 10 in base 10, that is. So it's not going to go in exactly the way we might expect. It's only going to go in 3 times, where 3 times 3 in base 4 is going to be 1 in base 4, but I'm not going to write that here. So what we're going to do is subtract 1 from 2 in there, and we'll be left with 1, and then we'll bring down the 2, so we'll have 2 in base 4, because obviously 3 doesn't go into 1 in the way that we want here. And to get rid of that, we should understand that 2 in base 4 is a 4 plus a 2, or a 6 in base 10, where if we want to figure out how many times 3 goes into 2, that means it only goes in 2 times, not the 4 times you might suspect, because remember, we're not dealing with this in base 10. It's very subtle. You have to be careful. It takes a lot of practice to see that that's what's going on. Really, division in other bases is kind of the crown jewel of everything that we've done with these other systems, at least in terms of arithmetic, because it really does take an understanding of everything with it. But anyway, this is going to end up being another 2, so thankfully here we get a remainder of 0, and we will have that our answer, our dividend that we're looking for, is 2 in base 4. Where if you want to be sure, 2 in base 4 is 14, and 2 in base 4 would be 2 16s, so 32, 2 4s, so 8, 42, 42, and 42 over 3 in base 10 is 14, or 2 in base 4, as we expect. And in particular for this, you're going to have to resist the temptation to not just convert to base 10 to do all your math, but this is how you'd handle it in base 4, which still requires a lot of care and a lot of understanding in terms of base 10 anyway. But those are all the things we're going to see for dealing with arithmetic in these other positional systems. The last thing we're going to get from this chapter is a return to history, as it were. We're going to see some systems that have some commonalities with the Hindu-Arabic, and then also others that don't, in particular where we're going to look at a couple of systems that are not positional, at least not in the way that we understand it.